Hi all, this is Lakshmi, working as Assistant Professor in the Department of PCE at SNSCT. So today I'm here to discuss about the topic oscillator in the course electronic circuits. So in the previous session we have discussed about the amplifier, how it works, and the common emitter amplifier as well as tuned amplifier. And now let us discuss about oscillator. So first, we must know the basic difference between amplifier and oscillator. So oscillators are generally used to generate the periodic waveform. But amplifier, what it does is it is going to increase the signal strength. It increases the amplitude of a input signal. So in that case, we provide an AC input signal, and that signal's amplitude is being increased with the help of amplifier circuit. But whereas the oscillator is going to produce a signal without any external AC input signal. It makes use of only the DC power supply to produce a AC signal. So this is the basic difference. And oscillator make use of positive feedback, and the amplifier will make use of negative feedback in its operation. So thus our oscillators would convert the direct current from the power supply to an alternating current signal. So these are mainly used in most of the electronic devices, and based on their output frequency generated, it can be classified in various types also. So in this session, let us discuss about Colpitt oscillator. So there are different types of oscillators like LC, RC, and the classification is done based on the frequency. So here, talking about LC oscillator, the oscillator circuit involves the amplifier part as well as the feedback part. So if the feedback part consists of L and C components, we call that as LC oscillator, and Colpitt is a type of LC oscillator. There are three types of LC oscillators like Colpitt, Hartley, and Clap oscillator. So here, let us discuss in detail about Colpitt oscillator. So Colpitt oscillator is going to make use of the inductance and the capacitance as the LC circuit in its feedback part. So you can see, so this is our Colpitt oscillator circuit. So here there is a amplifier circuit, which is a common emitter amplifier. So where we provide the output is taken from the collector and emitter will be common here. And this part is our feedback part. So here, when we have two capacitors connected in series and an inductor connected parallel, so this type we call it as Colpitt oscillator. This pattern, if C and L are connected, it is called Colpitt oscillator. And here we make use of NPN transistor. There is a voltage division which is given by R1 and R2. So this is acting as potential divider. And to improve the stability, we have included Rin, and the coupling capacitance C1 and C2 are here. So this is how the Colpitt oscillator circuit is built. So this portion forms the feedback part, and this forms the amplifier block. And for a circuit to work as an oscillator, there are two main conditions to be satisfied. We call that as Barkhausen criteria. That is called conditions of oscillation. So the first condition is that the loop gain, that is A beta, it should be equal to 1 in order to produce sustained oscillation. And the second condition is that the phase shift should be either 0 degree or 360 degree. Only then the circuit will produce sustained oscillation. So this is called Barkhausen criteria for an oscillation. So now calculating the frequency of this Colpitt oscillator. So we are going to calculate the impedance of the feedback components, like the impedance across the capacitance and the inductance are given by this expression. And from the general equation of the oscillator, we are going to substitute the values of Z1, Z2, Z3, and with the help of this relation, F is equal to omega by 2 pi, we can obtain the frequency of oscillation for Colpitt oscillator to be 1 by 2 pi root of C1 plus C2 by L C1 C2. So this is the frequency of oscillation. So now talking about the application of Colpitt oscillators. So they are widely used for high frequency application, and they can also be used in different type of sensors like temperature sensor, etc. And it is mostly produces undamped and continuous oscillation. In such applications, this can be used which require continuous oscillation, and it can also withstand high and low temperatures frequently. So these are the advantages. Hence, these are used in high frequency applications. So today's assessment is, the question is, in the Colpitt oscillator, the capacitance C1 and C2 and the frequency value is given as 10 kilohertz. We have to find the value of the inductor. So with the help of the frequency of oscillation equation, you can calculate the value of inductance by applying it in the formula which we have discussed now. So F is equal to, it is 1 by 2 pi, it is root of C1 C2 by L C1 C2. So applying in the formula, we obtain the value of the inductance. Thank you.